Hi everyone, I've got a bit of a cold today, so I'm a little bit nasally, but welcome to Discussion Board 4.4. My name is Kristen, and today my team and I will be presenting to you case study 9.2, which is called Baseball Card Emporium. So this case study is really based around the importance of understanding why collecting data is imperative to logistics. This is mainly because stakeholders are able to turn data into information, and this gives businesses the intelligence to make smart and timely decisions. This case study is a true example of how businesses across the supply chain can use information to make decisions, because using information to make calculations can potentially save entities thousands of dollars in logistics. This will be demonstrated in the case study today. So first up, I will be going through the case study with you. Then Andre will talk you through the case study information, followed by question 1. From there, Caitlin will be taking you through questions 2 and 3, and finally Nicholas will guide you through questions 4 and 5. All of these questions will include the appropriate formulas along with the solutions to these questions. And if you have any questions or need us to explain anything further, please feel free to post them on the discussion board because we are all here to help you this week. Alright, now that I've given you a bit of an introduction, I will talk you through the case study. Now I've nearly lost my voice, so just bear with me through my last slide. I'll read to you the case study. So this states that Baseball Card Emporium of Lordstown, Pennsylvania is a distributor of baseball cards to sport card retailers. Its market area encompasses most of Pennsylvania, Eastern Ohio, and New Jersey. The cards are printed in Nia, Wisconsin, and currently shipped to Lordstown via motor carrier transportation. Kenny Craig, Vice President of Logistics, has asked his staff to evaluate using air carrier service to ship the cards. So as you can see on the map below, Wisconsin is right at the top and Lordstown, Pennsylvania, the distributor, is right down the bottom, along with the sport card retailers in Eastern Ohio and New Jersey. So basically the Vice President of Logistics can see that the motor carrier time takes a lot longer than air carrier would, and is curious to how this is affecting the in-transit inventory carrying costs. We also need to take into consideration the cost difference of the motor carrying rate and the air carrying rate. So the following information and questions will be the guide to discovering if air carrier service will be the better option. Alright, thank you so much for listening to my case study. I will now hand you over to Andre.
Thanks for that, Kristen. Nick Ginger, Director of Distribution, has collected the following information on the Baseball Card Emporium. We will use this relevant information in relation to the EOQ model approach to calculate and analyze whether the Baseball Card Emporium should stay with their current motor shipping method or to change to a different carrier service such as air to ship their cards. We will be looking closely at the way the EOQ model approach can help us see differences in cost when calculating different rates, in which services are provided, and how it all plays a role in managing inventory. In order to measure total cost of a particular service, we need to evaluate things like the transit time and transportation costs. We calculate total cost of a particular service factoring in the following characteristics: inventory carrying costs itself, transportation costs, and in-transit inventory costs. Here is the economic order quantity, or EOQ, for Baseball Card Emporium in units, and also the weight in pounds for the units ordered. This order quantity helps an organization by having the most advantageous order quantity by ultimately minimizing carrying and ordering costs of that company. Here we see in step 1 to use the equation where Q equals the square root of 2 multiplied by demand multiplied by ordering costs divided by the total carrying costs. The above calculations are done based on the information stated by the Baseball Card Emporium, with values of R, annual rate of demand 6,000, A, cost of placing an order $75, V, value or cost of 1 unit of inventory $96, and W, carrying cost per dollar value of inventory per year 30% is given. As we solve for Q, as shown in step 2, we are left with a value of 177 cases. As we move on to step 3, to get the final value of the EOQ in pounds for the Baseball Card Emporium, we need to multiply the quantity ordered units by the unit weight of each case itself, which is 50 pounds, leaving the EOQ of the 177 cases ordered by Baseball Card Emporium to be a total of 8,850 pounds in total. We can now start to apply this EOQ value to work out equations 2, 3 and 4, where the total cost needs to be calculated for various types of services that Baseball Card Emporium will be using.
Thanks for that, Andre. Now that we know the economic order quantity, we can use this for question 2 to work out the total cost of the economic order quantity, excluding any transportation related costs. Using the economic order quantity measurement of 177 cases and the inventory carrying cost per unit per year, which is $28.80, we first worked out the annual inventory carrying cost for Baseball Card Emporium at $2,548.80. The second part of the equation refers to the annual ordering cost for Baseball Card Emporium. Using the cost of placing an order at $75, the annual rate of demand, which is 6,000 units, and again the economic order quantity measurement of 177 cases, this works out to be $2,542.35. Therefore, the total cost of Baseball Card Emporium's economic order quantity, not considering any transportation related costs, is $5,091.15. Moving on to question 3, we now incorporate Baseball Card Emporium's total cost of the economic order quantity with transportation costs. Baseball Card Emporium currently use motor carrier transportation to ship their cards, and this formula provides the total cost of using this motor car transportation method. The first two parts of this formula use the annual inventory carrying cost and the annual ordering cost for Baseball Card Emporium provided in the previous slide from question 2. The third part of this equation uses the motor car carrier rate, which is $1.20 per 100 pounds, multiplied by the annual demand of 6,000 units. The final part of this equation takes into consideration the inventory transit time of the motor car method, which is 4 days, the order cycle time at 7 days, the economic order quantity of 177 cases, the value of each case, which is $96, and the in-transit inventory carrying cost at 18%. Therefore, the total cost for Baseball Card Emporium to use motor car as their transportation choice is $14,038.92. Nicholas will now take you through the next question, looking at another transportation method for Baseball Card Emporium.
Thanks for that, Caitlin. Now that we've established the total cost for motor carrier transportation, we need to assess our alternative option, which is via air. The sum is derived the same way as the motor carrier, in which the exact same formula is used. The only variations are with the rate charged by the service provider, the inventory transit time, and the order cycle time. The air transportation rate is more than double the motor carriers, coming in at $2.50 per 100 pounds. The benefit of this service, though, is that the transit time is 1 day opposed to 4. Also, the order cycle time is much shorter, coming in at 2 days compared to the 7 of the motor carrier. Overall, the total cost for this form of transportation via air totaled in at $21,642.45. Now, ultimately, the purpose of questions 1 to 4 accumulate to help us answer our final question. Which alternative should the Baseball Card Emporium use, whether it be via motor carrier or via air carrier? As you venture downstream along the supply chain, it's noticeable that each player will have a different role. As the Baseball Card Emporium is a distributor, they must not only ensure they have strategical agreements with their suppliers, but also know what is important to their customers so that they can service both upstream and downstream adequately. With thanks to the economic order quantity model, otherwise known as the EOQ, we have learnt the optimum amount of inventory the Baseball Card Emporium should be ordering every time they make an order, and that was 177 cases, totaling at £8,850 per order. Basically, this method will help the Baseball Card Emporium mitigate storage and holding costs. So now the trade-off is whether the cost savings outweighs the transit time, as we know the air service is quicker but more expensive than the motor carrier service. We decided that the Baseball Card Emporium should utilise the motor carrier service, as the air carrier service is approximately 65% more expensive, which is quite a hefty amount. Not only was there major cost savings, but there were also other variables that we considered. One being that there are many less touch points when moving cargo via motor carrier. Simply, the freight is moved onto a truck, then unloaded at the receiver's premises. With the air carrier, it gets trucked to the airline, loaded onto the aircraft, unloaded at the destination, loaded onto the delivery vehicle, and then delivered to the end receiver. All these touch points via the air method increase the likelihood of pilferage and damage, both of which add additional costs to the Baseball Card Emporium. Therefore, our selection was basically use the motor carrier service. The team and myself would like to thank you for watching and listening to our presentation today. We're just going to leave you with a couple of questions that we hope you can answer. First one being, do you agree with our carrier method selection? And the second is, what alternative should the Baseball Card Emporium use if the air carrier rate was also $1.20? Please leave a comment and show all formulas and workings out if possible. Thank you.